We use the 2D Fourier transform method for CT image reconstruction to take the function f of x, y to the frequency domain and process it and get it back by inverse Fourier transform. So as you see here, p of phi of r, or the projection method, equals minus infinity to infinity f of x dy dx. Why is it ds here? You see no ds here. My guess because it's integrating with along the x-axis. That's according to the doctors. Okay, so when you take an intensity I naught and you take it and you aim it at an object, you would that object will go out as f of x, y, and as an intensity of IR. Now, how do we interpret this? We interpret this by converting it to the polar form, in which r is the frequency and phi is the angle, if you would like. Okay, so because you will make like this in the frequency, you will see it. So this would be r frequency, and what's changing here is called the projection method. This is not a Fourier transform here, not yet, because the Fourier transform, the 2D Fourier transform for f of xy is f of kx ky. Okay, as mentioned before, when we take the I naught and we aim it as at an object, it will give us a f of x of y. The changes is interpreted as f of x of y will be intensity IR. So we take the projection method out of this. How? By applying this formula, which is integration from negative infinity to infinity f of x y ds. As mentioned before, the ds, this thing, is because we integrate along the s. I guess this is, I don't know what it is, to be honest. R is the frequency, as I know. Okay, after taking the projection method, f of phi r, and taking the 1D Fourier transform of it, we will get this p of phi of k r. Now we are in the frequency domain. And how we get this? By using the 1D Fourier transform, which is from negative infinity to infinity, p phi of r e to the power of 2j 2 pi k r r. Why r? Because we want it at a certain frequency r, and the k is merely the sum of kx ky. Okay, now wherein we are in the frequency domain of kr, we put it into a grid and sample it, so it would be p of phi kr. What does that mean? Okay, we know what is kx and ky, which are this thing. We know it, yani they are in the axis. So what we want is to sample it like this. So kr is the magnitude. Okay, let's say that kr here, for the sake of explaining, is the magnitude, and phi is the phase or whatever you get, or the angle, sorry, whatever angle. So we take it at different samples. Okay, then we resample it. Why? To get the kx and ky of f of kxy, which is this. This is inside, is what we have here after resampling. If it is f of kx ky. So after we have this, we just take the inverse Fourier transform to get our original function, or our output, or whatever was here, which is f of xy. Here is the steps for doing such process. it is graphically and by words here. Sorry if it is not much of a help, but that's what I got. I understood and can clearly say. Others are